In 10.4, we're going to be creating box and whisker plots, and you'll see where they get their name from here as we start to create them. But the important vocabulary here is that a box and whisker plot represents a data set along a number line, but it uses 5 important values to create the actual box and whisker plot. And the 5 values that we're going to need in order to be able to make that box and whisker plot are the least value, the greatest value, and then the 3 quartiles basically. So remember, the first or lower quartile, the median, and then the third or the upper quartile are the values that we'll need, and then we'll connect them all to create that box and whisker plot. And just so that you know, in case anybody ever uses this phrase, 5-number summary over here, that's what they're referring to, are these 5 numbers or these 5 values that we just talked about. So if someone says, what is your 5-number summary, they're asking you for these 5 values to be able to create that box and whiskers plot. In example 1, we're going to be making a box and whisker plot, and they're asking us to make one for the ages in years of the spider monkeys at the zoo, and they give us this whole list of ages. So step 1 here is to put the order or put the data in order from least to greatest, and then find the median and the quartiles. So in order from least to greatest, we have 14, 15, 20, 26, 27, 3 30s, 33, 35, 36, and 38. And when we count, we can see how many data values that is. So that's 2, 4, 6, 8, 10, 12, which means we've got to go 3, 4, 5, 6 in here, and then we'll end up with 6 on both sides. But since both of the 2 middle values here are 30, then our divide, or our median, is still going to be 30. And then we're going to split our bottom half here, or our lower half, to find the first quartile. So again, we've got 6 values here, so we're going to go with 3 on each side, which means that we're going to have to first add these 2 center values, 20 plus 26, and then that's going to give us 46, and we're going to have to divide that by 2, which is going to equal 23. So we know our first quartile here, or our lower quartile, is going to be 23. And then for our upper half of data, again, we've got 1, 2, 3 here and 1, 2, 3 here, so it's going to be somewhere between the 33 and 35. And again, you can simply add those 2 together and divide by 2, or you can notice that between 33 and 35 exactly is going to be the number 34. So you can save yourself a little side math when that kind of thing happens, and you'll know that that's the third quartile. And then to complete our 5 data summary, or a 5-number summary, remember the other numbers that we're going to pay attention to besides the first quartile, the median, and the third quartile will be the least value and the greatest value. So these are going to be the most important numbers when we go to do the next step here. For step 2, we're going to break it into a couple of different parts, but the first thing you have to do is draw a number line that goes from the least value to the greatest value, and just like all of our number lines this year, you have to go in equal intervals. So I counted by 2s, you can count by anything, but that helps shorten it a little bit. So going from 14, which is our least value, to 38, which is our greatest value. And remember, when we do these kinds of things, that we do try to put our title down here, that this reminds us that the 14 and all of these other numbers are age of the spider monkeys in years. The next thing we're going to do is we're going to graph the points for the 5-number summary that we talked about, that list from before, above the number line. So usually when we did this stuff we said no floating dots, but in this case we're actually going to make those floating dots for a box and whisker plot. So these are the 5-number summary items that we just talked about, and again we put a dot above each one. So the least value was 14, the first quartile was 23, the median we figured out was 30, the third quartile was 34, and the greatest value on our list was 38. Step 3 also has a couple of parts, and the first thing is to draw a box using the quartiles. So when we do that, we're just going to kind of put a box, and obviously I'm not great at straight lines all the time, but you're going to kind of go through the middle of each of these. Ooh, I really went offline there. Through the middle of each of these quartiles here approximately, and make that box. And after you've made your box, then you're going to draw a line through the median, kind of going again right through that median there. And to complete this, then you're going to draw whiskers from the outside of the box at your quartiles to your least and your greatest values. So you can see now where it gets its name from. So you've got your box here, and then the whiskers are these long things that come out to either side. We're going to first mostly just practice making these, but again, to interpret it then, you can kind of look and you can see how spread out the data is, because this is another kind of way to show variability. So you can kind of see, I mean, the median of our data is right here in the 30s range, but it's kind of at the higher end of all of our data. So everything kind of looks like it's shifted over here to the right. And then there's not very much space between your median and your top end of data, but there's a pretty good gap between your median and your lowest end. So we'll be interpreting that in some of the next examples, but you'll start to notice, like, if your box looks kind of symmetrical or even on both sides, or if it kind of starts to get shorter on one side and longer on the other, that tells us a little bit about our data. And you'll look at your whiskers to see if they're equal to each other, or if you have one short whisker and one long whisker, and what that can tell us about our data. All right, I'm not going to make you copy this entire thing down, but this is sort of what I was just talking about, how it will talk about how the data is distributed in a box and whiskers plot. So remember, when we're looking at this, we're doing the 5-number summary from least value to greatest value, and we're using the lower quartile, upper quartile, and median. And so by definition, the range from your lower quartile to your upper quartile is going to represent about half of all of the data that you have. And then you've got a quarter on each side with your whiskers, because remember, 1/4 plus 1/2 plus 1/4 would be all 4/4 for your total set of data. And then, so what it tells us is a little bit more about just where the middle of the data lies and how much of the data is represented in that kind of middle range. So again, we'll practice that coming up, but just to kind of look at it. And then I am going to have you copy this part down, just to go back to what I was saying earlier. A long whisker or a long box indicates that the data is just more spread out. For example 2, we're going to look at how to just analyze and interpret a box and whisker plot. So they give us a box and whisker plot here that shows the body mass index, or BMI, of a 6th grade class. And you might have heard this term, body mass index, in like health class or at the doctor's office. They use it to compare a person's height and weight, to kind of see how healthy they are, how much body fat they might have, and all those kinds of things. So these numbers are all representing the students in a 6th grade class and their body mass index. The first thing we're going to look for is here, what fraction of the students have a BMI of at least 22? And to answer that, we're going to look here at the BMI, or body mass index, of 22. Whoops, I circled 21. 22, and we're going to see that that is where our box ends, so that would be like our 3rd quartile, and it's where one of our whiskers starts. And so if you go back to that last part that I just was showing in the video, we said about a quarter of our fraction, or of our data, is in each of the whiskers. So we would say about a quarter of the data, or the students, have a BMI of at least 22. The second thing that we're being asked to look at is, are the data more spread out below the 1st quartile or above the 3rd quartile? And then they want us to explain it. And again, if you can look, below the 1st quartile would be down here on this left whisker. Above the third quartile would be on this right whisker over here. And we can see this right whisker is clearly longer, which means that the data is more spread out. The last thing we're being asked to do to interpret or analyze this box and whisker plot is to find and interpret the inner quartile range of the data. And remember, to do the inner quartile range, we find the difference between the 3rd quartile and the 1st quartile. So we're going to actually subtract 19 from 22, which of course is 3. So what that tells us is the middle half of the students' BMIs varies by no more than 3. So we only go from 19 to 22 here for our quartiles, and so there's not much of a variation in the body mass index of these 6th grade students. And after we've gotten a little bit of practice in creating these, we'll spend just a little bit more time analyzing them and help figure out how we could use those a little bit more practically.